Let's see OOPS with real-time examples for testing in Java. OOPS, Object-Oriented Programming System, is a programming paradigm that relies on the concept of objects to create and manipulate data. Java is an OOP language, which means it supports the concepts of OOPS. Here are some examples of OOPS concepts in Java. Concept 1. Class. In Java, a class is a blueprint for creating objects. It defines the properties and behaviors of an object. You can see example of class on screen. In this example, the car class has two properties, color and speed, and one behavior, start. Concept 2. Object. An object is an instance of a class. It has its own set of properties and behaviors. You can see example of object on screen. In this example, my car is an object of the car class. It has its own color and speed properties, and it can call the start method. Concept 3. Encapsulation. Encapsulation involves hiding the internal details of an object and exposing only the necessary functionality through public methods. You can see some real-time examples of encapsulation in software testing on screen. Example 1. Test Automation Framework. A test automation framework is a collection of libraries, tools, and guidelines that help to create and execute automated tests. The internal details of the framework should be hidden from the end user, and only the necessary functionality should be exposed through public methods. Example 2. Test data. In software testing, test data is the input data used to test the functionality of an application. The test data should be encapsulated to avoid any accidental modification of the data. It should be accessible only through public methods, which ensure that the data is used in the correct way. In each of these examples, encapsulation is used to protect the internal details and ensure that only the necessary functionality is exposed through public methods. This helps to maintain the integrity of the data and the testing process, and avoid any errors that could be caused by accidental modification of the data. Concept 4. Abstraction. Abstraction in Java refers to the process of hiding complex implementation details from the user and providing a simpler interface for them to interact with. It allows developers, testers to focus on what an object does, rather than how it does it. You can see some real-time examples of abstraction in software testing on screen. Example 1. In Java, abstraction is achieved through the use of abstract classes and interfaces. Abstract classes are classes that cannot be instantiated and may contain both concrete and abstract methods. Abstract methods do not have a body and must be implemented by any concrete class that extends the abstract class. Example 2. Interfaces, on the other hand, are similar to abstract classes but can only contain abstract methods and constant variables. Classes that implement an interface must provide an implementation for all the methods in the interface. Example 3. GUI testing. GUI, graphical user interface. Testing involves testing the user interface of an application. The user interacts with the application through the GUI, but the underlying code that makes it work is complex. Abstraction allows the tester to focus on testing the essential features of the GUI without worrying about the complex code behind it. In all these examples, abstraction helps to reduce the complexity of the testing process by hiding the complexity of the underlying code and exposing only the essential features to the user. This makes the testing process more efficient and effective. Concept 5. Inheritance. Inheritance allows the creation of new classes that are built upon existing classes. In Java, inheritance is used to reuse code and to establish relationships between classes. Inheritance allows a class to inherit properties and behaviors from another class. You can see some real-time examples of inheritance in software testing on screen. Example 1. Test case inheritance. In software testing, test cases are usually written to test the functionality of a system. Test cases often have similarities, such as input and output validation, which can be inherited from a base test case class. For example, a base test case class might define methods for setting up and tearing down test data. And all test cases can inherit from this base class to take advantage of these methods. Example 2. WebDriver inheritance. WebDriver is a popular tool for automated browser testing. WebDriver provides a set of methods for interacting with web pages, and these methods are implemented differently by different browser drivers, e.g., Chrome driver, Firefox driver, etc. Rather than writing separate code for each browser driver, it's possible to create a base class for interacting with web pages, and then create subclasses for each browser driver that inherit the base class. Overall, inheritance in Java provides a powerful mechanism for reusing code and creating hierarchies of related classes, which can be especially useful in software testing. Concept 6. Polymorphism. Polymorphism in Java is the ability of an object to take on many forms. It allows a Java program to treat objects of different classes in a unified way. Polymorphism can be achieved in Java through method overloading, method overriding, and using interfaces. Method overloading allows a class to have multiple methods with the same name but with different parameters. Real-time examples, frames in Selenium. Basically, we can switch over the elements by index, by name or id, by web element. While method overriding allows a subclass to provide its implementation for a method already defined in its superclass. Real-time examples, example 1, list interface. The list interface can have different implementations like ArrayList, linked list, and vector. Each implementation has its own specific behavior and properties, but they all inherit from the same list interface. Polymorphism allows us to use the same method to add or remove elements from any type of list. Example 2, database class. A database class can be created to connect to different databases like MySQL, Oracle, and SQL Server. Each database has its own specific syntax and behavior, but they all have common methods like connect, execute, and close. Polymorphism allows us to use the same methods to connect to any type of database. You can copy the code from description. Don't forget to like, share, subscribe. Thanks for watching Sharat Amaraneni videos.